Okay, this is the checks for understanding from the last lesson. So if you haven't done it, then you need to stop and go and check your understanding on page 390. All right? So that x is a binomial random variable. Well, you know what you should be checking. Yes. Is it binomial? We're going to check the bins. Oops, can't see that. Okay. So, yes, success equals, it is binary. Success equals questions answered correctly. Failure equals questions not answered correctly. And independent, yes. Since the computer randomly assigned correct answers to the question, one trial should not affect any of the other trials. And number, yes, there are 10 questions. And so success, yes, the probability of success is 0.20, so for each trial. So since the number of x is the number of successes, it is binomial, a binomial random variable with n equal 10 and p equal 0.2. What is the probability that x equals 3, and explain what this result means? Okay, it is 0.2013, and there's a 20% chance that Patty will answer exactly 3 questions correctly. And then the last thing, to get a passing score on the quiz, a student must guess correctly at least 6 times. Would you be surprised if Patty earned a passing score? Compute an appropriate probability to support your answer. Okay. 0.0064 is our answer there, and there is only a 0.64% chance that a student will pass. We would be quite surprised if Patty was able to pass. All right. Okay, so we're going to talk about mean and standard deviation of binomial distribution. How can you calculate the mean and standard deviation of a binomial distribution? Well, the mean is n times p, where n is the number of trials and p is the probability of success. And to find the standard deviation, again, we're going to take the square root, because remember we're talking about variance, and so we take the square root of n times p times 1 minus p. And they are on the formula sheet, so that's good. All right. That wasn't supposed to be on there. Oh, well. Pretend it isn't. All right. We're talking about roulette again. Okay, so let x, this is an example, let x equal the number of the next 10 spins on the roulette wheel that land on black. Calculate and interpret the mean and standard deviation of x. So, here we go. Remember that we multiply the number of trials times our probability, and we get 7.737. And the standard deviation, that's big. Okay, so that is the square root of 10 times the probability times 1 minus the probability, and we get 1.579. How often will the number of spins that land on black be within 1 standard deviation of the mean? That's 1. Doesn't look like it, but it is. So, yep. Let me undo that. No. Whoops. There we go. All right. So, 1 standard deviation from the mean gives us 9.3 as our high end and 9.316 for our high end and 6.158 for our low end. And we want the probability that x is between those two numbers. Well, we're not going to deal with the fractions here. We're going to go between 6 and 9. So we have to subtract the probability of x is less than or equal to 5 from the probability that x is less than or equal to 9. So probability of x is less than or equal to 9 minus the probability that x is less than or equal to 5. Well, if I put it into that nice, beautiful, long formula, this is what that looks like. Now, for probability that x is less than 9, there's more on here, but I subtracted the probability for x is less than or equal to 5. So that's why it's shorter. It would be a heck of a lot longer than that. But thank goodness we have the calculator. So we're going to put into the calculator the binomial CDF of 10, 18 divided by 38 and 9, remember. And then we're going to do minus the binomial CDF of 10, our number, probability, and 5. And we get 0.3135, which means that about 31% of the time, and I didn't finish typing this, I should have, when you spin, it'll land on black within 1 standard deviation of the mean. So that's that. Okay, check your understanding. Now you need to go ahead and stop and go check your understanding on this, see if you got it, and welcome back. So, find the mean of x and interpret that value. I know you love these interpretation things. Y'all need to get used to it. So, the mean of x is 2. And what that means is we would expect the average student to get 2 answers to correct on that quiz. Wow. Okay, not good. Find the standard deviation and interpret that value in context. Okay? And the standard deviation, we would expect individual scores, student scores, to vary from the mean of 2 correct answers by an average of 1.265 correct answers. And what's the probability that the number of Patty's correct guesses is more than 2 standard deviations above the mean? Show your method. Okay, there's my method. I want it to be above 4.5. The probability of x to be greater than 4.53. So I'm going to do 1 minus the probability that x is less than or equal to 4. And I get 0.0328. All right. And binomial distributions in a statistical sampling. And this, I think we just ran out of paper. I mean, we just had this extra little bit on this. This probably should be in the next lesson, but it's okay. It's all good. So, when is it okay to use a binomial distribution when sampling without replacement? Okay, you can use binomial distribution as long as your sample size is 10% or less of the population. It is also known as the 10% condition. And the end.